Makers virtual show and share. On this Tuesday, I think we have about 4 shares and then some announcements. So we're going to go ahead and get started with. First I want to mention, if you want to share, then please send us an email at SAS, that stands for show and share, at knoxmakers.org. Anybody, you don't have to be a member to share and join us, so just send us an email and we'll hook you up on how. First up, we have Dawn, who's going to show us some vinyl stickers. Dawn?
Hi. Okay. Yeah, so I just got in a new car and kind of wanted to personalize it, so I decided to take a crack at working with the vinyl cutter at the space. Basically, what I did is I got a blank plate off like Etsy for like a couple bucks, and then so the plate actually is the white part, and so basically I did a reverse kind of embed.
Oh wow!
So like all the green is like a car green chrome vinyl, so it won't fade in the sun. It took me about maybe 4 or 5 tries to get it lined up perfectly, because I was going, okay, I put it on there, and like I would hold to the light, and going, nope, that's crooked, and take it off again, put it back down again. But I was able to get down, and it's working pretty good. I had to do some little extra loving with the heat gun to help the vinyl relax some, because there were a few creases in there from taking off and putting
did
it back on.
Did the heat gun work well with that?
Yeah.
Oh, nice.
Yeah, so it helped relax the vinyl so that it would reset. It was mainly around some like corners. It was just kind of like not liking the bending so much, but I found that using the heat gun helps it kind of relax and gives it extra stretch, so it pulls tight around the edges of the plate.
So Isaac has a good question. He's saying, were you able to reposition the same piece, or did you have to reset the vinyl?
Yeah, it was the same piece. So it's basically kind of like I put it down, but I didn't like press it down. It was more kind of like a soft set, so it only maybe stuck in a few areas, and then I was able to kind of eyeball to see where it was, if it was corner or not. So then I was able to pull it off. Luckily, so that made it a little bit easier, but yeah, and using the heat gun also helped make sure that there was no like air bubbles within it.
Right. It looks great. I really thought it was the white lettering when I first saw it, but that turned out really nice.
Yeah, the only main, I think there's another picture in the next slide. Maybe, I'm not sure. Yeah, so the main problem I found out is that I was going to put it on the front of my car, and then I found out that my front car doesn't have like connectors for a plate, because it was like the first time I got like a recent vehicle, because I was like, wait, cars don't have that normally anymore. So I basically kind of jury-rigged it. I got like a mounting plate, and then I used some 3/4-inch PVC pipes cut to about 1 inch long to kind of stick it out, and then I used extra long screws with some washers to mount it so it'd be away from the grill, but it stayed on so far. It hasn't fallen off. Nice. And then I got like a clear plastic cover to make sure, like, so that the weather doesn't kind of pull away at any of the corners, especially.
Yeah. So what does it mean?
So the top row is Iwate, and I used to live in Japan, and that's the prefecture I lived in. Okay. 83 is the year I was born. The character on the left just means say. It's one of the random characters that we can use. Weblinks is my derby name, because I ref roller derby, and everyone in derby has like a derby name. And then I went to Ohio University, and their mascot's a bobcat, and one of their old logos was the paw print.
Very nice. Well, that was amazing results, man. You did a good job.
Thanks.
Very cool. Thank you for showing that.
Yeah.
All right. Next up, we're going to have Ray going to show us some high voltage. I hope there's a live demonstration.
You bet there is. I'm getting the hint, you guys. The last time, my titles are too long. The last time you shrunk the font size down and chopped one word off, now you're down to just high voltage. Eventually, it's just going to be Ray is high, and I'll deny it. So let's see. A couple or a few weeks ago, I presented a 170 volt low current supply that I was working on. I've since got boards back, got parts in, and built it, and had the results for that. In case anyone's interested in learning more, I threw a class on the calendar where I'll just walk through this design in a lot more detail. So if you're someone who's interested in electronics, would like to pick up some tidbits, or just out of curiosity would like to see more, I'll walk through it in quite a bit more detail. We've had a few requests like that in the electronics channel before. So so I want to put that together. Yeah, go ahead to the next slide. Let's see, so what this is used for, this is actually used to provide some limiting of power going into an offline power supply when you're initially testing it. So an offline power supply just means it plugs into the wall in your house. That wall provides probably something like 120 volts at 20 amps, which is 2,400 watts. A lot of voltage, a lot of currents, a lot of power. If you go hooking that straight up to some circuit you've put together, if you just have any maybe problem in the circuit, something that needs to be refined or debugged, a small short, a solder problem, whatever, you can get a lot of smoke, a lot of fire, and damage a lot of components. So what you'd like to do is kind of bring it up easily and see if things are working right and debug or fix any problems, hopefully before you blow things up or before you blow a lot of stuff up. So that's the intent. So what we've got is the picture here shows 120 volts plugging into the wall. Then an offline supply, usually you do something like rectify up to 170 volts DC, then you do a DC to DC conversion to whatever you're going to power. And this is something that would kind of replace that first block in here. Next slide. So this is the whole schematic. I won't go through this in detail, but from a high level, there are sort of 4 different sections. There's the power supply itself, and that's what I've talked about in the past related to this supply. That's in yellow. In blue, there's a high voltage bleeder circuit. I've actually talked about that before and showed the results of that circuit in some prior show and shares. I added a couple of LED indicators. What I found was I was still nervous about whether I knew 100% absolutely for sure if that high voltage bleeder was working. I found a very, very unusual case I'd probably never run into, but I did find a very odd case where it didn't seem to be discharging properly. So for additional safety reasons, I put a couple of LED indicators. So you can see when it's plugged into the wall, when that's hot, and then you can see when high voltage is still present. So that's just sort of a little extra safety measure, which has been super convenient to have. Next slide. So I'm not going to go through a bunch of this detail. This is kind of a little bit of a teaser again for next week. I would go through what each of these components are doing and how they work in the class. But this is a little circuit I put together. I say I put it together. I mean, these things have been around for years. So this isn't like a new patented invention. This is stuff you can find. But there are many ways to do this. I think this particular method works quite nicely. And it's kind of interesting. It's not as easy as putting a resistor in series with an LED like we're used to. You need to do a little more trickery around it to make it both safe and not dissipate a lot of power and that kind of thing. So that's what I put together there. That shows, that just indicates, is it plugged into the wall? Do you have the 120 volts feeding it? Next slide. And then a similar kind of a thing on the high voltage side. So there's 170 volts up there where it says VREC. That's a rectified voltage. I regulate that down to 12 volts to go feed an LED. So that's just a linear regulator in the middle. Drop a little power before it so that thing doesn't get too terribly hot. And then on the right of that, the 12 volts to an LED is much more like something we would commonly see in the normal hobby world. Next slide. Let's see, and this is the power supply schematic, just a little more detail there. The way it works is first, on the left is what's plugged into the wall, literally the wall, well, it could be the wall outlet. I actually have other equipment that a series of pieces of equipment I plug it into instead of the wall to provide some other safety and ramping. This is just a straight up fuse, some inrush current limit, bridge rectifier, capacitor. So if you're familiar with linear power supplies, you'll have seen that kind of thing before. And that just rectifies 120 volts AC to 170 volts DC. Then the next section is a current set and current kind of sense and limit section. There are just 4 jumpers, and you can put your jumper in whichever position you want it to be in for however much current you want to make available, 10, 50, 100 milliamps. Then on the right is just a pass element, which is normally just on and just lets voltage through and current through, unless too much current is detected, and then that thing starts getting shut down. So on the right side of that is your actually 170 volts current limited output. Yeah, next slide. And this is the actual board as built. I'm proud to say there's no smoke and no char marks on this particular one, or if there were, I cleaned it off before I showed it. So on the left side, that's where the 120 volts is coming in. You can see a fuse there, a little bridge rectifier next to it, that kind of rectangle looking thing. And then on the upper left, that's a LED that indicates when 120 volts is hot. I actually feed this with a transformer, a variable transformer, so I can plug that into the wall. I started at 0 volts. There's just a big old knob you can turn and turn it up from 0 volts to your normal full 120 volts. And you see, as soon as you have very much voltage at all on there, the LED lights up. So if you're feeding pretty much anything interesting to that, interesting in terms of dangerous, you're going to see that LED lit up. Then on the right side, you've got some outputs and stuff, which I was clearly testing there, and an LED that indicates when the 170 volts is present. So it's kind of nice. You can really quickly, as you're working, typically this is just sitting off to the left, you're working on a power supply over to the right. You can just glance over and see, is it safe to shove my fingers in this thing before you actually do it? Next slide, please. This is the actual measured results. So what you've got here is on the left side, the left axis, that's the voltage that's being put out. And then the bottom axis, the x-axis, this is as I draw more current. So I just put a load, a variable load on the output, and just dial the load up in terms of current up and up and up and up until you see it shut down. This is at 3 different voltages, at a rectified voltage of 50, 100, and 170 volts. And it was, as you can see, about 10 milliamps at 50 volts. And then you go along at 100 volts, it shuts down at whatever that is, closer to 11, 10 and a half, and then at 170 volts it shuts down about 11 and a half or so milliamps. One of the things I was concerned about is when I short the output, which can happen if you have a fault in whatever you're hooking up to it, you can short the output, is does a pass element overheat? And I thought I'd be okay, but was slightly nervous about that. And it did remain pretty cool when it was shorted under worst case conditions. So the measured data looks great. Real happy with that. Next slide. And this is just looking at the discharge circuit. There were really no major changes in this from what I've presented before, but what I was interested in was what did the LED actually look like? I knew it was going to be fine in terms of getting below 50 volts. So 50 volts DC is sort of the conventional threshold for a dangerous voltage. Above that, you consider it dangerous. Below that, it's considered safe. So from a turn-off state, it's down to 50 volts in a little over 4 seconds, which is great. And I was curious, though, at what point does the LED really dim? And it really gets pretty dim when the output's sitting at about 9 volts, which is about 8 seconds in. Let's see, and that's it. That's what I've got on this guy. So the measured results look fantastic. It's put together. Now it's sitting in the toolbox of things on the test bench here that I can use down the road for my future projects. Thanks.
So when you say that you rectify from AC to DC, is that right? What does that mean exactly?
So in the wall, actually, if you were to look at the voltage on the 2 prongs in the wall where you plug in your toaster oven or refrigerator, if you look at that, that voltage varies. It actually goes from 0 up to 170 volts, and then back to 0, and then down to negative 170. So it alternates in a sine wave pattern from plus 170 to minus 170 volts. So that's what that looks like. Most electronics things that we have, like computers, digital ICs, our phones, all this stuff, they need a constant voltage. So voltage that varies like that you can't power semiconductors or most displays or most things with that. You normally need to convert it to a constant voltage. So if you look at a DC voltage and you look at that, it's just always, for example, 12 volts or always 5 volts all the time, kind of like your car battery. So it converts that voltage that varies from plus or minus 170 volts to just a constant 170 volts.
Okay. So it's just making it a constant, taking it from a variable to a constant. Is that what the rectify term means? Because you hear rectify a lot in electronics, but I never exactly knew what that meant.
Yeah, that is one use of rectification. Sometimes they might use it slightly different terminology, but basically that's pretty much what's going on, something like that. And then it's common in these offline supplies. You just rectify it up to roughly 170. It varies a little, but roughly 170 volts. So you just have a constant 170, and then you just do a normal conversion down from that to whatever you need to power your laptop or whatever you got.
Right. Well, thank you.
And Isaac wants to see me get shocked. I'd have to be running the video camera then. And then I'd have to share it. I would deny it.
All right. Well, thank you very much.
Right. Thank you.
All right. Next up, we have Tracy, who's going to show an embroidered calendar.
Yeah, so I really like Christmas countdown calendars because I made one at the Space 2 years ago. But this is a really old project from when I lived back up north from 2009. I found some pictures from back then. So what it is, it's a Christmas countdown calendar, and each of the embroidery hoops has a number on it, and then on the other side is a picture from a storybook that we would read to our son every night. So when he was little, so it was like leading up to Christmas. If you go to the next slide, I think is a close-up of some of the numbers. It's sort of a terrible picture, but each one had a number, and then you turned it around, and the next slide is some of the pictures on the other side. So it was from a Bible storybook, and each day going up to Christmas was a different Bible story. So we had Adam and Eve and Noah's Ark and the snake, and I don't remember what they all were at this point, but it was a certain book, and I just took pictures. I took stories from the book and made a little picture for each one. So if you go to the next slide, there's all of them on the wall, turned around as you got closer to Christmas. You could see and those were all hand embroidered. And the last slide, I think, has a bigger picture of all the different. And I didn't include the last one. That was the one I liked the best. It was like Mary and Joseph and the baby. But I guess I forgot to put that slide picture in. But so that was my little embroidery project for that year. I don't think we had a tree that year, so that was like our Christmas decoration for that year. And that was my maker project.
Were the numbers in math that you had to figure them out to do them?
Some of them were, because, have to make my kid do some thinking or something, I guess. I don't know. I tried to make them all different.
Right.
And then different pictures for the other side. So that was my project that year, way back a long time ago when my kid was real little and cute. He's still cute. He's just not little anymore.
Right.
That's my project.
Very cool. What are you going to do this year?
I don't know. I should just make a new countdown Christmas calendar every single year, right?
You should.
I'll take ideas. If anyone
Then
has any
eventually you
ideas
can
for
make a
Christmas
meta
countdown.
calendar that counts down every day until Christmas with its own self-contained calendar. Each day has its own calendar in it.
I could do
Recursive
that.
calendar.
I could do that. So that's what I've got.
Thank you. Very cool. All right, Chase. You want to show us your lateral hold downs?
Sure. Am I coming through all right?
You are.
All right. So this project is not the massive board in the middle there, but the two little things on either side. And I've just been sort of playing around with different ways of holding down things on the CNC. So I wanted to try these little like cam levers. I don't know exactly what to call them. If you want to go to the next slide, you can see it a little closer. But the idea is you just kind of put these things, you thread them into the spoil board and you kind of crank them over. And I think the next slide kind of shows the shape of it. Yeah, that's not the best one. Maybe the next one shows like the footprint, but it's this little cam thing. So as you sort of swivel this thing around, you wedge like more and more material, um, between the bolt and what you're trying to hold down. So if you get two of these, or you have like one of these and something to like hold the workpiece on the other side, and you crank it over, it pinches it in there and it kind of keeps it from moving around. So, I see these on a lot of like hobbyist homemade CNC machines, and the complaint I hear is that, well, the complaint I hear is that you can't always get enough range of movement, or you can't get enough material to like actually reach the workpiece depending on where it's positioned. Maybe just, yeah, let's see the next slide. It might make a little more sense. So maybe one more. So here we go. So the range of movement on each of these levers is about 1/2 inch, but the spacing on the spoil board is about 2.5 inches. So there's sort of like a no man's land in between if your piece isn't exactly the right, if it doesn't fall within a certain distance of one of these little holes where you can put these things in the spoil board. So the solution to that is you can get like a piece of scrap wood, or something to kind of fill in that gap. But I like to make things overly complicated, and I didn't feel like having to keep track of a bunch of different size spacers and have scrap pieces of wood that look like scrap pieces of wood that could get thrown out or mixed up or whatever. So the idea with this is these little square things that go under it, and each side, the thickness of it increases by 1/2 inch. And the range of travel on these levers is 1/2 inch. So theoretically, at least, you should be able to fit anything. You should be able to, like, the range should work out where you can hold just about anything without having to go and grab another scrap piece of wood. So
that's very slick, yeah.
So if you skip through these, you can actually see sort of the range and the different configurations just by turning these things. So it starts at 12 inches and it goes all the way down to 9. So you can actually just skip through these pretty quick. So there's a range of 3 inches, and the spacing on the spoil board, I think, is about 2.5 inches. So let's see. Yeah, the gantry. I haven't actually used these specifically, but I did use these same knobs to hold down like the more traditional ones where it's like holding on top of the workpiece as opposed to pinching in from the side. And I just, I checked before I ran the program, and there wasn't any collisions with the knobs. So with these, I think as long as the knobs are the overhanging parts. Yeah, if you want to go back to the very first one, you can kind of see the idea like in practice. So they should be, as long as your stock size is set up right, I think they should be pretty far out of the way. Yeah, so they're the little knob parts secure it down to the spoil board, and then you can actually, I have it here with me. So the idea is you put this thing down on the spoil board and you wrench this thing over, and it sort of puts that extra material, pushes it in, and moves this whole thing over. So these things are all off to the side, and if everything's set up right, I don't think you have to worry about collisions or anything, because the stock should be like the entire surface of the stock doesn't have anything on it, right? All that clamping force is coming from the side. But so that's the idea. I hope it makes sense. It's not really the easiest thing to explain with pictures.
Yeah, it's very cool.
I tried them out. I actually made these yesterday and tried them out. And, they got a fair amount of clamping force. I only have 2 of them, so they need, something else to help hold down the workpiece for now. But I'm planning on making a couple more and trying those out and seeing if that's, solid enough. But yeah, they work really well. I'm pretty pleased with it, and I don't have to keep track of a bunch of random thicknesses of scrap wood.
Yeah, that's a very, very cool design there, a very smart design, where you basically just have all the sizes you need built in just the pieces there, instead of having to carry the scrap around.
Yeah. So
That's very cool.
Theoretically, it should be able to clamp just about anything.
Yeah.
We'll see how that works. But yeah, these are at the space, so if anybody wants to use them, feel free to.
Yeah, for sure.
That's it.
Did you make them with the CNC?
I did, yeah. And I initially kind of thought of them as a 2-sided operation before I would machine, sort of have this side on the spoil board and machine this side where the lobe, like the lobe or the cam or whatever it is, and then flip it over and put a little recess to put a washer or something in. But I thought, well, I already have these little knobs, and they've got a pretty big bearing surface on them. So, and since it's all off to the side of the stock, I didn't think this extra height here would be a big deal. So, I just foregoed the 2-sided milling, just did, I actually did 4 of these pieces. I only have 2 of these, but I'll make a couple more. So, big matched set. But yeah, without they actually work really well with this knob thing, and you don't need any tools to swap it out, which is kind of nice.
Yeah, I always think it's very cool when you use the tool to make accessories for the tool.
Yeah, it's like that an MC Escher drawing of the hand drawing the hand, like the 2 hands drawing themselves. I love the idea of using machine to make things for the same machine.
Yeah, very cool, man. Thank you for showing that off.
Sure, my pleasure.
You do some really cool things with that.
Yeah, thanks.
I'm looking forward to seeing more. Thanks, man.
Me too. Yeah.
All right. Some announcements. We have some classes coming up. Several thanks to Ray. This one is tomorrow. You can't get a ticket anymore, but if you did, you should have gotten your kit already. If not, yell at Ray. We all do. And then show up for tomorrow's class. It's going to be a soldering class virtually, so that should be pretty interesting. I'm looking forward to that. Then we have Saturday. We have several slots, a few slots left. Brian is doing some different wood shop classes, get people authorized, or he's also doing a sharpening demo. Is that right? On Saturday, and so there's a few. He's doing those in one-on-ones, and so he has 1-hour slots to sign up for on the website. So if you want to take part in that, talk to him or or buy a ticket so that you can do that. That's this Saturday.
I think the sharpening demo is sold out.
Oh, sorry. Well, there's still the wood shop. I think there's still a few tickets for the wood shop 1 hour off classes. And then Ray is going to do an LM7805 regulator class. Maybe you can say a couple of words about that. I don't know what that is.
Oh, sure, happy to. So anyone who's into electronics may be familiar with the LM7805. It's like a super ubiquitous linear regulator that's used all over the place. A lot of us have used them. And I was just going to go through a little bit about how semiconductors are made. And we can kind of tear one of these open and look under the hood and see a little bit about how it works, what's inside there, what are all these little squiggly lines on the integrated circuit, what are those functions of those things. It's just that kind of thing. Fairly casual and fun and informative type of thing. Not super technical, just a little bit, but not too much.
Yeah, okay. What over a grand overview? What does one of these do?
So it converts one DC voltage to another. A 7805 converts to the 05, means it converts the output to 5 volts. So you can put whatever you want on the input, and it will convert it to 5 volts on the output.
No, very cool. Very cool. And then you talked a little bit about this one already. There's a high voltage power supply class on the 13th. That last one was, what was it, the 12th? And then the 13th, yes. And then you're leaving out of town for a while, right?
Then I'm gone for a while. I'll see you guys sometime in September. Yeah, and this one is intended to be a little more technical. So parts of this, a casual electronics person would probably follow along and enjoy. There will be parts of that that's probably a little more on the intermediate advanced side. So it'll have a little bit of range to that.
Very cool. All right, and then one more mention of SAS at knoxmakers.org. If you want to show something off or just want to take part, send us an email and we'll get you set up. And then with that, that is all of our shares for the night and announcements. So we're going to stop our recordings and open the cameras up for chat.